we have to prepare a buffer of pH 9. Since pH is greater than 7, this is a case of basic buffer. So we will need weak base and salt of weak base. As the buffer component. We will use the following steps. For preparation of this buffer. And the first step is selection of conjugate acid base pair. So we are looking for a weak base and salt of weak base. The choice of base is determined by desired pH. For our case, pH is 9. We can also calculate pOH because pH plus pOH is 14 at 25 degrees centigrade. So pOH is 14 minus pH and pH is 9, so pOH is 5. So pOH is given. Now we know for basic buffer is most effective when pOH is equal to pKb, and this is approximately equals to pKb. So we are looking for a base that has pKb value very close to pOH, that is 5. And if we see the table, NH4OH, that is ammonium hydroxide, has pKb value 4.74. So we have identified the weak base. So for this buffer, we will use ammonium hydroxide, and other component will be salt of ammonium hydroxide, let us say NH4Cl, ammonium chloride. So we have two components, ammonium hydroxide and ammonium chloride. The next step is calculation of ratio of buffer component concentration. And for this we will use Henderson-Hasselbalch equation. That is POH is equals to pKb plus log concentration of salt by concentration of base. POH is 5, pKb is 4.74. So ratio of these two concentration is equals to 10 raised to the power 0.26. So let us calculate this value. So this is 1.81. So concentration of salt is 1.81 times concentration of base, or we can say mole of salt is 1.81 times mole of base, because volume of solution remains constant. Now for this buffer, ammonium chloride is the salt and ammonium hydroxide is the base. So we can say per mole of ammonium hydroxide (1.81 mole) ammonium chloride is needed. Now the next step, calculation of buffer concentration. Generally, we use concentration of weak base is around 0.5 m, and this also depends upon what kind of a stock solution is present in lab. So choice of concentration of weak base depends upon a stock solution present in lab. This also depends upon buffer capacity. Higher the concentration, of weak base, higher the buffer capacity. Let us say we have 0.5 m NH4OH and we have to prepare 1 liter buffer. This means moles of ammonium hydroxide is 0.5 into 1, that is 0.5 mole. Now mole of ammonium chloride is 1.81 times 0.5 and this is 0.9 mole. We can also calculate weight of ammonium chloride, that is 0.9 into molecular weight of ammonium chloride. So let us calculate this value. This is 47.25. So we need 47.25 gram of ammonium chloride. And finally, we have to mix two buffer component. So we have weak base ammonium hydroxide 0.5 m and we will add ammonium chloride of 47.25 gram so that final volume of solution becomes 1 liter. So sufficient amount of ammonium hydroxide is added so that final volume of solution becomes 1 liter. So this is a way to prepare a basic buffer.